Hi everyone, it's Mrs. Ligon. Happy Friday. We're going to pick up with the example that we left off with yesterday about the air travel data. So, if you remember from yesterday, the graphic shows regional air travel data recorded by a domestic airline company. How can you use the data to estimate the number of air miles people flew in 2003? If the trend in the air travel continues, what is a reasonable estimate for the number of miles that people will fly in 2030? So first thing I'm doing is I'm labeling each of the years with some numbers that are going to be a little easier to work with. So you can see I'm going up by 5s, I'm starting with 0. If you look at the number of years, you'll see that these years are the numbers since 1975. Most of the data we look at will be labeled like that, years since whatever year. So in labeling this, it's much easier to work with 0 and 5 and 10 and 20 than it is to work with numbers like 1975. So our years since 1975 are going to be our X value, and our air miles traveled is going to be our Y, our actual Y value. So this is the actual amounts of air travel. Now we're going to put this into our calculator. The Y is going to go into column B when we open up our spreadsheet file, and the X is going to go in column A. Even though the data is written side to side, you put it into the columns going down. Once you have your data entered, you're going to go to Menu, Statistics, then Stat Calculations, then you're going to select Linear Regression, MX plus B. It's important to choose the MX plus B option because that's the format we've been using for our equations, and it's just going to confuse things if you use the A plus BX one. After you select linear regression, your X list is going to be A with the brackets. Remember, you get the brackets by hitting Control and then the left parenthesis. Our Y list is going to be B with the brackets again. Then you're going to go down and select OK, and you're going to generate your linear regression equation in that Y equals MX plus B format. Now to find the number of air miles in 2003 and 2030, we're going to have to plug certain numbers into that linear regression equation. So for 2003, we're going to plug 28 in for X, because 2003 is 28 years since 1975. For 2030, we're going to plug in 55 years, because that's how many years it's been since 1975. And again, that's going to get plugged in for X in the regression equation. When you solve the regression equation after you've plugged those numbers in for X, that's what's going to give you your predictions for how many people flew in 2003 and how many miles people will fly in 2030. So this is an example of how we can use this linear regression in a business or other formats like this to predict what's going to happen based on data trends. Next, we're going to take a look at the worksheets in the packet. So the first one we're going to look at is the additional vocabulary support, scatter plots, and lines of fit. That should be the front page of your packet. For this sheet, basically all you're doing is either filling in the definition or the image. These are definitions that we've been using the whole time we've been doing regression, so you guys should be pretty familiar with them. So you can see that the first line, trend line, already has all three parts filled in. The definition, a line that models the data in the scatter plot by showing the general direction of the data. And then you can see in the picture that there's that trend line drawn in the scatter plot. When we get down to the next line, positive correlation, it's already given us the definition, but you guys need to draw a scatter plot that's going to illustrate that definition. You can use the scatter plot for negative correlation to give you a little bit of a guide of what kind of picture I'm looking for you to draw. For negative correlation, you're going to write a definition. The definition for a negative correlation is going to be a lot like the definition for positive correlation. So you can use that again as a guide. And then for the last option, the no correlation, you're going to sketch an example, just like you did in the positive correlation section. This one should be pretty quick and easy for you guys. Like I said, since we've been working with these terms all week. All right, so sorry that my voice just cracked there. I guess my allergies are catching up to me. So the next worksheet we're looking at is this enrichment one for scatter plots and lines of fit, the second page in your packet. So now we're going to apply some of those definitions and some of those things that we've been doing. So we have a group of students is preparing for a Regional Scholar Bowl, a competition quiz game. The students start by taking a general knowledge exam. The exams are scored and the students start to work with their faculty advisor, Mr. Rodriguez, to improve their performance. After 2 weeks of study and practice, the students test again with a different exam. The scores are provided on the table below. In question number 1, they've already made the scatter plot and drawn the trend line for you. So all you have to do is write the equation. So how do we write the equation? I'm going to take you guys through the step because you're going to need to do this in some of the later worksheets. So this is going to be really important. Make sure you follow along and ask the substitute to pause the video for you if you start to fall behind. So we're going to be using the form y equals mx plus b like we've been using for all of our linear regression equations. So we need to find our y-intercept first. That's the area where the line would go through the y-axis. So in this case, our b is going to be that y-intercept point. So b is equal to about 105. You can see it's a little bit above that one where the 100 line would be, above the 90. And it's all right to kind of estimate for this. Now we need to find our slope. To find the slope, we need to pick 2 points on the line. I like to try to pick points that are near the grid lines because it's a little bit easier for me to see where the point is, but you can pick any 2 points on the line that you want. So on the grid lines of this point that I drew, my x-intercept is going to be 60, and my y is going to be 90. Those are my coordinates for that point. Then I'm going to go over here to my y value of 82 and my x value of 90. Slope is equal to the change in y over the change in x. So what we're going to do is subtract our first point from our second point. So I've got 90 minus 82 over, oh wait, I just did my second point subtracted from my first point, so I need to switch those numbers around. So it's going to be my second point minus my first point. So 82 minus 90, that's my change in y. And then it's going to be over my change in x, which is going to be 90 minus 60. I'm going to do that subtraction. I'm going to get 8 over 30, actually negative 8 over 30, because 82 minus 90 is going to give me a negative number. Then I can simplify this fraction further, and I'm going to get negative 4 over 15. Sorry, I'm kind of squeezing that in. I'll write it bigger over here for our equation. So we have y equals, and then our m value, our slope, negative 4 over 15, x, plus our y-intercept, which we put at 105. So this would be our equation for the scatter plot and trend line of this data. So you should be able to do the rest of this worksheet on your own. It's asking you to think about this a little bit more. And you're going to do the same thing for these two scatter plots. So you're going to make a scatter plot for group A and for group B, using the first test as your x value, the second as your y. Then you're going to not just create the scatter plot, but you're also going to draw the trend line, or the line of best fit, and you're going to write your estimated equation for that line of best fit. So I'm adding some directions to this worksheet, but you should be paying attention and following along. So when I go to grade these worksheets, I'm going to be looking for the line of best fit and the estimate of the equations of the lines. If you want to be really precise, you can use your calculator to figure this out, but I'm fine with the estimates like I showed you in problem 1. All right, the next worksheet is the additional practice, analyzing the lines of best fit. Just a little extra clarification on those directions. The type of correlation, what I want to know is it a positive or negative correlation? And whether or not it's strong or weak. We've talked about what it means to have a strong or a weak correlation. A strong correlation coefficient is going to be closer to 1. Weak is going to be further away from 1. I like to use 0.5 as my cutoff point. Greater than 0.5 is going to be a strong relationship. Less than 0.5 is going to be weak. For problems 6 and 7, you're going to use your calculator to find this regression equation, just like we did in the example with the airplane. So we've been practicing that a lot, especially in our packet. You guys should be good with that. If you notice in the table, the years are all years since 2002, just like we did with the airplane problem. So 2010 would be year 8, which you notice is missing from the table. And 2018 is going to be year 16. Our last worksheet on the last page is the enrichment, analyzing the lines of fit. You're going to make a scatter plot for each set of data by drawing it on the table below. Then you're going to draw the trend line and make the approximation, which is just like what we did on the earlier worksheet where we estimated our trend line equation by finding the y-intercept and the slope. Then we're going to use our calculator to find the actual line of best fit. And I want you guys to compare how similar your estimated equation is to the actual line of best fit that your calculator comes up with. And you will do the same thing for both of the tables of data. Again, this is good practice because you want to be able to predict the costs of things, what's going to happen. And regression and lines of best fit are basically your way of using math to be able to predict the future. I hope you guys have a great weekend. I'll see you on Monday when we will have a quiz on this information.